Okay, so get this. We're diving into a world where we can manipulate things at a billionth of a meter small. Like, can you even imagine that?
Yeah.
That's nanotechnology. And it's not some, like, far-off thing. It's already here. It's impacting everything around us already, from, like, the clothes we wear to, believe it or not, the medicine we take.
Yeah.
And you've sent in a really interesting mix of sources this time, so it seems like you're really trying to get a grasp on how this whole nano thing is going to play into achieving those UN Sustainable Development Goals, those 17 big goals for a better world.
It really is like we've been handed this incredibly precise set of tools, and we're just starting to understand what we can actually build with them. What I find fascinating is that nanotechnology isn't limited to just one field. It's applicable across so many disciplines, offering solutions in areas as diverse as medicine, energy, agriculture. It's even being used to tackle things like poverty and hunger.
Right. That's exactly what caught my eye, too. It's like this hidden engine driving progress toward those goals. And most people have no clue it's all happening on such a tiny scale. We've got this, I have to say, pretty dense but amazing paper from Science Direct that lays out all those connections. And then on the other end of the spectrum, we have these excerpts from a futurist who's predicting nanorobots are going to have us all living past 120. But before we go down that particular rabbit hole, let's set the stage. Basics for anyone new to the nano world, right?
Absolutely. Let's start there. So, nanotechnology, it's all about manipulating matter at the atomic and molecular level. We're talking about working at the nanoscale, which, to put it into perspective, is 1/1000th of a meter. To give you an idea of just how small that is, think about a sheet of paper. It's about 100,000 nanometers thick. What we're talking about is thousands of times smaller than that.
That is mind-blowingly small. I don't even think I can wrap my head around that scale. So how did we even get to the point where we can manipulate things that tiny?
It's a journey, really, one that spans decades. You can trace it all the way back to 1959, this physicist, Richard Feynman. He gave this lecture, there's plenty of room at the bottom, and it was a defining moment. He basically predicted a future where we could manipulate individual atoms and molecules. A bold vision, especially for the time. The technology to even attempt it just didn't exist.
It does sound like he was way ahead of his time. So how did we go from this incredible vision to actually being able to, work at the nanoscale?
It was a gradual process, for sure, with breakthroughs happening along the way. In 1974, a scientist named Norio Taniguchi actually coined the term nanotechnology, giving a name to this emerging field. But it was the invention of something called the Scanning Tunneling Microscope, or STM, in 1981 that truly revolutionized things. This was the game changer. For the first time, we could actually see individual atoms. Imagine that.
Wait, hold on. We could actually see atoms. That must have been absolutely groundbreaking for the scientific community.
Oh, absolutely. It's like suddenly having a new, incredibly powerful lens to see the universe's building blocks. Just think about it, seeing the atoms that everything around us is made of.
That is.
hmm
I mean, it's hard to even fathom. So what kind of impact did that have on the whole field of nanotechnology?
Oh, it blew the doors wide open. Possibilities were just endless. In 1986, Eric Drexler wrote this book, Engines of Creation, and it really captured everyone's imagination. He predicted some pretty wild things. Nanotechnology could achieve building materials atom by atom, creating molecular machines, even those nanorobots everyone's talking about, the ones that could revolutionize medicine.
Okay, you said nanorobots, and now I have to ask.
Yeah.
Are we anywhere close to having these tiny robots, swimming through our bodies, curing diseases?
Well, while we aren't quite at the point of having fully autonomous nanorobots cruising through our bloodstream, nanomedicine itself, that's incredibly exciting, and we're making huge leaps. We've already come a long way in using nanomaterials for super-targeted drug delivery. Imagine, zeroing in on a disease. That has the potential to change how we treat diseases forever, and we're only just getting started.
It's incredible how far we've come since Feynman's, initial vision. We've gone from barely being able to comprehend the nanoscale to actually messing with matter at the atomic level. But I have to admit, some of this still feels a bit like it's straight out of science fiction.
I get that. I totally get that. But what I find fascinating is how nanotechnology is actually drawing inspiration from nature. The Science Direct paper you mentioned earlier, it makes this really interesting analogy of mimicking nature's superpowers at the nano level.
I love that. We were looking to nature for inspiration on how to solve problems, even at the nanoscale.
Exactly. One great example is self-cleaning surfaces. Scientists have been studying the lotus leaf. It's got this unique nanoscale structure that makes it naturally repel water and clean itself. And now we can copy that structure, which means self-cleaning stuff for everything. Clothes, solar panels, you name it.
Oh, right. I've seen those ads The clothes that never stain. That's insane that it all goes back to mimicking nature, but at the nanoscale. What other, superpowers is nanotechnology unlocking?
Well, artificial photosynthesis is a big one. Just like plants use sunlight to turn carbon dioxide and water into energy, scientists are developing artificial systems using nanomaterials to do the same thing. Imagine harnessing the power of the sun for clean energy, just like plants do.
That would be revolutionary. And then there's the whole world of nanomaterials, right? Things that are, stronger and lighter than anything we've ever seen before, like synthetic spider silk.
You got it. Spider silk, it's like nature's own super material, right? It's crazy strong, super lightweight. Scientists have been trying to recreate its properties forever. And now, thanks to nanotechnology, we're getting closer than ever. I'm talking materials that could revolutionize everything from how we build airplanes to, like you said, construction.
Okay, so let me get this straight. We've gone from barely being able to see atoms to using them to create self-cleaning surfaces, artificial photosynthesis, super strong materials, all inspired by nature. It seems like the possibilities are literally endless.
They really are. And the exciting part is we're already applying these breakthroughs to tackle some of the biggest challenges our world faces, which brings us back to the UN Sustainable Development Goals.
Right, those 17 goals. A blueprint for a better future, as they say. So where do we even begin to unpack how nanotechnology fits into all of that?
Well, the beauty of those Sustainable Development Goals is that they're all connected, kind of like a jigsaw puzzle. Progress in one area often ripples out, creates progress in others, and the fascinating thing is that nanotechnology has the potential to boost those ripples, to speed up progress towards pretty much all of them.
Okay, I'm ready to get specific. Which of these goals really jumps out, when we're thinking about the impact nanotechnology could have?
Let's start with a big one. Goal number 1, no poverty. Nanotechnology has incredible potential when it comes to creating solutions that are actually affordable and accessible, especially in areas that are super critical for lifting people out of poverty. Things like healthcare, access to clean water, agriculture, especially in developing nations where resources are already stretched thin.
That makes total sense. So it's about leveling the playing field a bit, using nanotechnology to make those essential resources available to everyone, no matter where they live or how much money they have.
Exactly. A great example of this is happening right now in India. They're using these incredibly low-cost water filters that use silver nanoparticles to get rid of contaminants from drinking water. It's providing safe drinking water to communities that very likely wouldn't have access otherwise. It's a real-world example of how powerful this technology can be.
That's amazing. Safe drinking water is something that so many of us take for granted, but it's literally a life or death issue for millions around the world. What about goal number 2, zero hunger? How can nanotechnology help us feed a growing global population?
This is where things get really interesting. Imagine a world where we could, supercharge crop yields, massively reduce waste, and boost food security. All through nanotechnology. It sounds futuristic, I know, but it's already happening.
Okay, you've definitely got my attention now. Tell me more. How does this even work?
One really promising area is nanofertilizers. These are tiny particles that deliver nutrients directly to plant roots with incredible accuracy. It means way less waste and a reduced need for traditional fertilizers, which, let's be honest, can be really harmful to the environment. It's like giving plants a vitamin boost, but super targeted.
That's incredible. So not only could we be producing more food, we could be doing it in a way that's way more sustainable. Are there other ways that nanotechnology is being used in agriculture?
Oh, absolutely. They're developing these nanosensors that can constantly monitor soil conditions, giving farmers data in real-time nutrient levels, how much moisture is in the soil, even if there are pests or diseases. It's like giving farmers a microscopic look at what's happening in their fields.
That's wild. It's like having a team of tiny agricultural experts working around the clock. Amazing. What other, innovations are on the horizon when we're talking about nanoagriculture?
Well, we're already seeing nanotechnology being used to create entirely new food packaging materials. These new materials can actually extend shelf life and drastically reduce spoilage, which is a huge deal, especially in developing countries where access to refrigeration just isn't a given.
So we're talking about reducing food waste, increasing efficiency, and ultimately making sure there's enough food to go around. Seems like nanotechnology really has the potential to completely revolutionize our entire food system.
And the best part is, this is really just the tip of the iceberg.
This is all so fascinating. Before we get into the next goal, I have to ask. Remember that article about nanorobots making us all live to 120? Goal number 3, good health and well-being. Should we be taking that seriously, or is it just good science fiction?
While the idea of nanorobots, swimming through our bloodstreams and repairing damage at a cellular level, that might still be a few years or decades away, the reality of what we can do with nanomedicine is really exciting. For example, we're making huge strides in targeted drug delivery, and that has the potential to revolutionize how we treat diseases.
Okay, so less sci-fi, more practical stuff. What are we talking about here specifically?
Think about it this way. Instead of something like chemotherapy, which, as we know, comes with some pretty nasty side effects, imagine delivering cancer drugs directly to tumor cells using nanoparticles. This targeted approach could mean treatments are more effective and have fewer side effects.
That's incredible. It sounds like we're on the verge of a medical revolution. But what about those futuristic predictions of nanorobots actually performing surgery or even, like, reversing aging?
Those scenarios, they might be a few decades off. However, there are researchers right now, as we speak, working on developing really tiny robots that can deliver drugs or perform minimally invasive procedures. So the potential is definitely there. That said, it's important to manage expectations a bit and focus on the more immediate ways nanomedicine is already making a real difference.
So targeted drug delivery is a reality. Nanorobots are still in the works, and living to 120 is, well, a bit further out there.
Exactly. But even without achieving those really futuristic scenarios, the field of nanomedicine is already changing healthcare in some pretty incredible ways.
Okay, let's move on to goal 6, clean water and sanitation. I feel like I can already see how nanotechnology fits in here.
Right. It's a perfect fit. One of the biggest challenges we face globally is access to clean water, but with nanotechnology, we're coming up with these really advanced filtration systems that can remove even the tiniest, and I mean tiny, impurities from water bacteria, viruses, heavy metals, everything.
It's like having a molecular sieve for water.
That's a great way to put it. And it's not just about filtering out contaminants either. Nanotechnology is being used to desalinate seawater, turning it into a viable drinking water source. Especially for coastal communities dealing with water scarcity, this could be huge.
Desalinating seawater using nanotechnology. That just sounds unbelievably complicated.
It's definitely a complex process, but it is becoming increasingly efficient and affordable because of nanotechnology. Imagine a world where water scarcity is a thing of the past, where we can give everyone access to clean drinking water no matter where they live.
That's definitely a future I can get behind. Are there any real-world examples of this technology actually working?
There are. Singapore's New Water project is a great example. They're using a combination of nanofiltration and reverse osmosis to literally recycle wastewater into high-purity drinking water. It's a huge success story.
That's really inspiring.
Yeah.
Okay, let's switch gears to goal 7, affordable and clean energy. I'm curious to hear how nanotechnology is impacting this area, especially with, the ever-increasing need for sustainable energy sources.
This is another area where nanotechnology could completely change the game. I'm talking about developing way more efficient solar cells, better batteries, more efficient energy storage, all because of nanomaterials and their unique properties.
Okay, so how does it work? Give me the, nano details.
Okay, so imagine solar cells that can capture more sunlight and convert way more of it into electricity, all thanks to things like quantum dots. Or picture batteries that store way more energy, charge faster, and last longer. That's where nanomaterials like graphene and carbon nanotubes come in.
So we could have lighter, smaller, more powerful batteries for everything. I mean, from our phones to electric cars. This is blowing my mind.
It is mind-blowing stuff. And the impact on renewable energy could be huge. Imagine a world where we can generate and store clean energy more efficiently than ever before, reducing our reliance on fossil fuels.
That's the dream, right? A future where we're powered by clean, sustainable energy.
It is. And nanotechnology is bringing us closer to that reality.
This is all incredibly exciting. But before we get too carried away with all the amazing possibilities, let's take a step back for a second. Let's consider the potential downsides of all of this.
You're right. It's super important to acknowledge that anytime you have a new technology, there are potential risks, challenges that come with it, and we need to be aware of those as we get further into this world of nanotechnology.
So let's talk about those concerns.
Yeah.
What are some of the things that people are worried about when it comes to nanotechnology?
Well, one of the biggest concerns is the potential impact nanomaterials could have on human health and the environment in general. These particles are so incredibly small that it can be hard to predict exactly how they might interact with living organisms, or the environment long term. There's that old saying, nature bats last. We need to be careful that we're not creating a whole new set of problems while we're trying to solve others.
Right, like some kind of microscopic boomerang effect. What are some specific examples of those potential risks?
Well, take nanoparticles, for example. Their size gives them all these unique and potentially useful properties, but it also means that they might be able to get past our body's natural defenses. We need to be 100% sure that any nanomaterials used in things like medicines and cosmetics are safe, and not just in the short term, like long-term use.
So it's not just about making sure it works. It's about making sure that it's safe for both people and the planet down the line. What's being done to address those concerns?
Well, there's a whole growing field called green nanotechnology. It's focused on developing sustainable and environmentally friendly approaches. That means things like making sure they use biodegradable materials, reducing waste during production, and figuring out how to safely dispose of or recycle those nanomaterials at the end of their life cycle.
That's good to hear. It sounds like there's a real awareness of the need to be, responsible as we dive headfirst in this whole nanotech revolution. But it can't just be about the science itself, right? But we also have to think about the ethical side of things, how this impacts society as a whole.
Absolutely. One of the biggest challenges is going to be figuring out how to ensure equal access to these new technologies. We've seen it happen over and over with new innovations. The benefits often end up going to those who are already at an advantage, while others get left behind.
It's like that old saying, the rich get richer.
Exactly. We have to be intentional about making sure nanotechnology is used to close the gap between those who have and those who don't, not make it wider. That means thinking about affordability, accessibility, and even cultural considerations.
So it's about more than just inventing incredible new things. It's about making sure those things are available to everyone, no matter how much money they make or where they happen to live in the world. What about misuse? Could nanotechnology be used to create new weapons or other technologies that are, well, harmful?
It's definitely a concern that's been brought up, and it's something that we need to be very aware of. Any powerful technology can be misused, and nanotechnology is no different. There are already discussions happening about its potential use in surveillance and even in warfare.
See, that sounds a little ominous, like we're walking into an episode of Black Mirror or something. What can we actually do to prevent nanotechnology from being used for, bad stuff?
That's where international cooperation becomes really important. We need to establish some ethical guidelines for research and development, kind of like what we've already done with other powerful technologies like, nuclear energy.
So getting ahead of it, setting boundaries early before things get out of hand. But how do you even begin to regulate something as complex and, let's be honest, rapidly evolving as nanotechnology? I mean, where do you even start?
It's a huge challenge, no doubt about it. It's going to require everyone working together: scientists, policymakers, industry leaders, and, most importantly, the public. We need to be having open and honest conversations about the potential risks and benefits, and most importantly, how we can responsibly manage its development and use.
Transparency and open communication seem to be key here. We can't just leave it up to the so-called experts to make decisions about something that has the potential to impact every single one of us.
I wholeheartedly agree. Public awareness and engagement are absolutely crucial. The more people understand about nanotechnology, what it can do, what the risks are, the better equipped we are to make informed decisions about its future.
It's about making sure everyone has a voice at the table.
Exactly. And I think that's one of the things I find most exciting about this entire field. Nanotechnology has the potential to be truly transformative. But ultimately, how it's developed and used, that's up to all of us. It's a shared responsibility.
That's a powerful message to end on. We've gone from exploring how nanotechnology could solve some of the world's biggest problems to acknowledging that, hey, there are potential risks and we need some ethical guidelines in place. It feels like we're at a crossroads with this technology.
We are. The decisions we make today will determine what our future looks like with nanotechnology.
So as we wrap up this part of our deep dive into the world of nanotechnology,
Right.
what are some key things our listeners should take away?
I think the biggest thing to remember is that nanotechnology is still in its very early stages. It has incredible potential, but we also need to think carefully about what it could mean for the world, for everyone. Stay informed, ask questions, and most importantly, get involved in the discussions happening around its development.
Don't be afraid to be curious, to dig deeper, and to demand transparency.
Exactly. And remember, the future of nanotechnology isn't set in stone. It's up to all of us to shape it in a way that benefits all of humanity and the planet.
And on that note, we're going to take a quick break. But don't go anywhere. We'll be right back to continue our deep dive into the fascinating world of nanotechnology. Welcome back. We're diving back into the world of nanotechnology, and so far it seems like it has the potential to really shake things up when it comes to achieving those UN Sustainable Development Goals. But right before the break, we started talking about some of the potential risks, too. It's a good reminder that we need to be smart, really think things through about how we're developing and using this powerful new tool.
Couldn't agree more. We can't just race ahead with the can we do it without also asking, should we? It's like, and I know this is kind of a crazy analogy, but it's like giving a toddler a chainsaw, right? Amazing potential for sure, but you better make sure you've got some serious safety measures in place first.
Okay, that's both hilarious and terrifyingly accurate at the same time. So as we're exploring how nanotechnology plays into all of these global goals, let's all try to keep those safety glasses on, metaphorically speaking, of course. Where are we headed next on our little nano adventure?
Well, how about goal 9? Industry, innovation, and infrastructure. This one's all about building that resilient infrastructure, the kind that lasts, promoting sustainable industrialization that's inclusive, and of course, encouraging innovation.
When I hear infrastructure, I immediately picture bridges, highways, things like that, big tangible stuff. How does something like nanotechnology even fit into that picture?
You might be surprised. Nanotechnology is making big changes in material science. Imagine for a second building materials that could actually heal themselves, like nanomaterials embedded right into something like concrete. Those nanomaterials could actually repair tiny cracks before they even become a problem. That means structures last longer and we don't have to spend as much on repairs.
So we're not just talking about making things bigger and stronger, but also making them smarter and way more sustainable, too.
You got it. And it goes beyond concrete, too. Nanotechnology has the potential to make solar panels even more efficient, which means they become cheaper and more accessible. It can improve batteries, which is huge for electric vehicles, and making renewable energy more practical. And if you think about it, these are all advancements that contribute to Goal 9, but they also tie directly into our fight against climate change, which is Goal 13.
It's really mind-blowing when you think about it. Something so tiny having such a huge impact on things like construction and energy production.
That's the thing about nanotechnology. It's all about precision, engineering at the smallest level imaginable, and those tiny changes can lead to these massive improvements in the materials and technologies we depend on every single day.
Okay, so we've talked about clean water, affordable energy, even buildings that can practically heal themselves. But how does nanotechnology play into creating more sustainable cities and communities? That's Goal 11, right?
Think about the biggest problems that cities are facing these days. Pollution, traffic that never seems to move, infrastructure that's, well, let's just say it's seen better days. Nanotechnology could be the answer, a way to address all of those challenges.
Okay, I'm not going to lie. I'm having trouble picturing it. Give me an example. How can something so small fix something as big and complicated as a city?
Let's take air pollution. Some cities, like Mexico City, are already ahead of the curve here. They're using these special coatings on buildings, coatings that have nanoparticles in them, to actually clean the air. These coatings neutralize harmful pollutants, so the air people are breathing is cleaner and safer.
That is incredible. It's like we could be cleaning the air at the nanoscale. What about other ways that nanotechnology can make cities more sustainable?
Oh, there are tons. Imagine a system that manages traffic flow in a city, but it uses nanosensors to do it in real time. It could adjust traffic signals and actually reduce congestion. Or buildings that monitor their own energy use using nanosensors, they could adjust the lighting, the temperature, and everything to cut down on waste.
Yeah, that's what I call a smart city. It sounds like nanotechnology could be the key to making our cities more efficient, greener, and just, better places to live.
Exactly. And this actually ties into another goal that's super important, Goal 8, decent work and economic growth.
Okay, I get the innovation part and how it can create new industries, but how does nanotechnology specifically create better jobs?
Well, for one thing, the nanotechnology industry is booming right now. It's creating all kinds of jobs in research, development, manufacturing, and even implementation. These are the kind of high-skilled jobs that pay well, which of course helps boost the economy.
So it's about more than the technology itself. It's about the opportunities that get created around it.
Exactly. And as the technology keeps advancing, we can expect to see even more of those opportunities popping up.
That is good news, especially with all the talk these days about automation and robots taking over jobs. It seems like nanotechnology could actually be a huge job creator in the future.
It definitely has that potential. But it's also up to us, right? We have to make sure that those opportunities are available to everyone, not just a select few. Which actually leads us to Goal 10. Reduced inequalities.
That's an incredibly important point. We definitely don't want nanotechnology to end up widening the gap between the haves and the have-nots. How do we make sure that everyone benefits from this technology, not just the privileged few?
It all boils down to equitable access. We have to be deliberate about making sure everyone reaps the benefits, not just the wealthy countries or those at the top of the income ladder. Like we talked about earlier, those low-cost water filters, that's a step in the right direction towards clean water for everyone. And as we're developing new nanotechnologies, whether it's in medicine, agriculture, or energy, we have to keep things like pricing and distribution in mind. Make sure they're attainable for the people who need them most.
It's a good reminder that every time we see technological progress, we need to be thinking about social responsibility too. We can't just invent cool new things and hope for the best, assume they'll magically reach everyone who needs them.
I totally agree. It takes a real conscious effort, collaboration, to make sure these technologies actually benefit all of humanity.
So we've talked about how nanotechnology could create jobs, address inequality, even make our cities better. What about its role in gender equality, which is Goal 5?
I know this one might not seem as obvious, but nanotechnology can actually be a powerful tool for women and girls. Think about agriculture for a second. Women often face a lot of obstacles in that field, access to resources and technology being some of the biggest ones. But now, imagine if nanotechnology could help level the playing field. What if it gave women farmers access to those precision tools we talked about earlier? Nanofertilizers, nanosensors, even crops that are more drought resistant, all thanks to nanotechnology.
It's about making sure everyone has the same opportunities to succeed, no matter their gender.
Exactly. And this applies to more than just agriculture. Nanotechnology is being used to develop things like better sanitary products, which can have a huge impact on the lives of women and girls, especially in countries where access to proper sanitation is a real struggle.
It's incredible to think about something as small as nanotechnology playing a role in these really significant social changes.
It just goes to show how transformative this technology can be.
Okay, let's shift gears a little bit. I want to talk about how nanotechnology is being used to tackle environmental challenges. We touched on climate action with Goal 13, but I'm curious about its impact on things like our oceans and land ecosystems. That's Goals 14 and 15, right?
Right, you've got it. Goals 14 and 15 are all about protecting the life in our oceans and on land, and that's essential if we're talking about a sustainable future. And you guessed it, nanotechnology offers some really promising solutions.
Okay, give it to me. Give me some hope for our planet.
All right, so let's start with our oceans. We all know plastic pollution is a massive problem. But imagine for a second if we could use nanomaterials to make plastics that actually biodegrade, plastics that just break down naturally in the environment. Or we could use nanotechnology to clean up those disastrous oil spills. Imagine nanoparticles acting like tiny little sponges, soaking up the oil and minimizing the damage to marine life.
Those would be game changers for sure. What about protecting life on land? What can nanotechnology do there?
Well, for one thing, nanotechnology can be used to clean up contaminated soil and water, like actually remove pollutants, things like heavy metals and pesticides. That's huge when it comes to helping ecosystems that have been damaged by pollution or industrial activity recover.
It's like giving those areas a much-needed detox.
Yeah, in a way it is. And it's not just about cleaning up the messes we've already made. Nanotechnology can help us develop agricultural practices that are more sustainable. That means depending less on pesticides and fertilizers that we know are harmful.
It's about working with nature, not against it.
Yeah.
I like the sound of that.
Me too. And it doesn't stop there. We can use nanotechnology to track endangered species, monitor the health of forests, and even fight deforestation.
Wow. So nanotechnology is being used on all these different fronts to protect the planet.
It really is an incredibly versatile tool when we're talking about tackling environmental challenges.
Okay, we still have a few goals left on our list. But before we dive into those, I want to shift gears for just a minute and talk about the ethical stuff. It's all well and good to talk about the amazing things nanotechnology can do, but we also need to make sure that we're using it responsibly.
You're absolutely right. We can't lose sight of the potential unintended consequences. Just like any powerful tool, there's always a chance it could be misused.
So, as nanotechnology keeps advancing, what are some of the ethical things that we need to be thinking about? So before the break, we were getting into some of the, let's call them ethical gray areas around nanotechnology. Like, yeah, it has amazing potential, but we also need to make sure we're using it responsibly.
Right, exactly. We can't just assume everything will be fine because, hey, it's tiny and cool. There are some real concerns we need to be thinking about.
Like what, specifically?
Mhm.
What are some of those ethical dilemmas we need to be prepared for as nanotechnology keeps developing?
Well, I think one of the big ones, and we kind of touched on this earlier, is that whole idea of unintended consequences.
Hmm.
We're talking about manipulating matter at such a small scale. Like, it can be really tough to predict how those materials are going to interact with, living things, the environment, all that in the long run.
Right, like it could be decades before we realize we messed something up.
Exactly. And by then, it could be too late. It's like, I don't know if you've ever seen the sci-fi movie.
Oh, yeah. Where they create some tiny thing to solve a problem and it, like, takes over the world.
Exactly. Now, I'm not saying that's going to happen with nanotechnology, but it's a good reminder that we need to be really cautious. We don't want to create a whole new set of problems while we're trying to solve the old ones.
Right, like some kind of microscopic boomerang effect. You were going to give some specific examples of those potential risks.
Oh, right. So think about nanoparticles for a second. The fact that they're so tiny gives them all sorts of unique properties, which is amazing, but it also means they could potentially sneak past our body's natural defenses.
You mean like get into places they shouldn't be able to?
Exactly. So we need to be absolutely positive that any nanomaterials we're using in things like, medicine or even cosmetics are actually safe for people and not just in the short term. Long-term use is what we need to be thinking about.
So it's not just about does it work? It's about is it safe for everyone and is it safe for the planet down the line? You said there's a whole field focused on making nanotechnology safer and more sustainable.
Yeah, it's called green nanotechnology, and it's a growing field for sure. They're all about coming up with environmentally friendly ways to work with nanotechnology. So things like using biodegradable materials whenever possible, cutting down on waste during the production process, and figuring out ways to dispose of or recycle nanomaterials safely.
Okay, that's good to know. It seems like people are at least aware of the need to be careful and responsible as we're, going full speed ahead with this nanotech revolution. But it's not all about the science itself, is it? We also have to think about what all this means for society as a whole.
You're absolutely right. And one of, I think, biggest challenges with any new technology is making sure it's accessible to everyone. Historically, we've seen that the benefits of new innovations tend to go to the people who are already, well off, while others miss out.
It's that whole the rich get richer.
Exactly. So we need to be really, really intentional about making sure that nanotechnology is used to close that gap between the haves and the have-nots. It shouldn't be making it worse.
So that means thinking about affordability, about access.
Yeah.
It can't just be something that only certain people can afford or even know about.
And it's not just about the money either. We need to think about things like cultural differences, make sure that technology is being developed and implemented in a way that's sensitive to different cultures and beliefs.
It's about making sure everyone benefits, not just a select few.
Okay, what about the potential for misuse? Like, could someone use nanotechnology to create, I don't know, new weapons or other technologies that could be harmful? It's something that's definitely on people's minds, and for good reason. We have to remember that any technology, especially something this powerful, has the potential to be used for things that aren't so great. I mean, there are already discussions happening right now about the implications of nanotechnology for things like, surveillance and even warfare.
Okay, see, now that is kind of scary. It feels like we're wading into, like, Black Mirror territory.
Yeah.
What can we actually do to stop that from happening, to prevent nanotechnology from being used for, bad stuff?
Well, this is where things like international agreements and cooperation come into play. It's going to take countries working together to establish some very clear ethical guidelines, not just for research, but for development too. Sort of like, what happened with nuclear energy.
So getting out ahead of it, drawing some lines in the sand before it's too late. But how do you even regulate something as complex and fast-moving as nanotechnology? It seems like a moving target.
It's a huge challenge for sure. It's going to require scientists, policymakers, industry leaders, everyone really working together. And really importantly, the public needs to be involved in this conversation. We need to be having open and honest discussions about nanotechnology, the good, the bad, the potential, the risks. That's the only way we're going to be able to manage it responsibly.
Transparency seems like a big part of it. We can't just leave it up to the scientists and governments to figure this all out. Everyone needs to be informed.
Right, exactly. The more people who understand nanotechnology, how it works, what it can do, the better equipped we'll be as a society to make smart choices about its future.
It's about making sure everyone has a voice, that everyone's informed.
That's what it boils down to. And honestly, I think that's one of the most hopeful things about this field. Nanotechnology really does have the potential to completely change the world for the better. But at the end of the day, it's up to us, all of us, to make sure it's used for good.
It's a shared responsibility. Well said. Well, we've gone on quite the journey here. We've explored how nanotechnology could help us solve some of the world's biggest problems. And we've talked about the potential downsides, the things we really need to be cautious about. It's clear that we're at a really critical point with this technology.
We are. The decisions we make today, right now, will determine what the future holds for nanotechnology.
So as we wrap up this deep dive into the world of nanotechnology, what are some key takeaways for our listeners out there?
I think the biggest one is to remember that this is still really early days for nanotechnology. It's exciting, it's promising, but it also requires, like we've been saying, some careful thought and consideration. Stay informed, ask questions, and don't be afraid to get involved in those conversations about how it's being developed and used.
Don't just assume someone else is handling it.
Yeah.
Be curious, dig deeper, ask the hard questions, and demand transparency.
Absolutely. And lastly, but most importantly, I want people to remember this. The future of nanotechnology isn't some predetermined thing. It's up to all of us to steer it in a direction that benefits all of humanity and protects this planet we all share.
I love that. It's a powerful note to end on. It's been a fascinating journey exploring this incredible world of, well, really, really small things and their potentially huge impact. Thank you so much for joining us.